Hi, my name is Damon, and this is my COMP3132 Assignment 1 for the Fashion MNIST dataset using current and TensorFlow. In this video, I am going to show you how I load and explore the datasets built and trained in neutral network and compare two different training configurations and evaluate the model's performance. Fashion MNIST is a dataset of 60,000 training images and 10,000 test images. Each image is a 28 by 28 grayscale image, represent one of 10 clothing categories such as t-shirts, trousers, sneakers, and bags, or etc. Compared to the original MNIST dataset of handwritten digits, Fashion MNIST is more challenging because many clothing items have similar shapes and textures, which makes classification harder. After loading the dataset, I print the shapes of the training and test sets. The training images have a shape of 60,000 by 28 by 28, and the test image have a shape of 10,000 by 28 by 28. The labels are one-dimensional arrays that match the number of image. I display the first few labels to see how the classes are encoded as numbers from 0 to 9. And I also printed and plot the images in index 5 in the training set of index 500 in the test set. This helped me visualize and confirm how raw pixels value translates into actual clothing images and what each numeric label represents. Before training, I normalize the image data by dividing all pixels by 255, and this scales the value into a range between 0 and 1s, which helps neutral networks train faster and improve numeral stability. And I also add a flattened layer to reshape each 20 by 28 image into a one-dimensional vector of 784 Newton, which is required for fully connected dense layers. For option A, I compiled the model using the Atom Optimizer and sparse category cross entroven as the loss function. And this setup directly works with numeric class labels. And for option B, I use the RMSprop optimizer category cross intern as the loss function, and this requires converting the labels into one-hot encoded formats before training. Both models were trained for Tensorflow, and I trained training accuracy and validation accuracy during the process. Compared to standards MNIST, Fashion MNIST is harder because the clothing items look similar in shape and texture. For example, the shirts and pullovers or sneakers or ankle boots can be visually close, which makes classification more difficult. And this also explains why overall accuracy is usually lower than what we typically achieve with handwritten digits. In conclusion, this project demonstrates how to pre-produce image data, build and train a neutral network, and compare the different optimizations and loss function strategies. And that's it. Yeah. Thank you for watching.